In this video, we will touch on the basics of science and the scientific method. So chemistry is a branch of the physical sciences, and students in the physical sciences study the natural world. This includes components of the physical universe around us, as well as the natural forces at work on those things. The aim of scientific inquiry is to produce more accurate models of how the natural world works. And more recently, the goal of some scientific research is to solve a problem or develop a new technology. Now, most of you in this class are engineers or pre-medical science students, and both of these fields require hands-on applications of scientific principles and the scientific method. So let's look at what science is. My general explanation of science is it is the tool that we use to explain natural phenomenon. Okay, and I have a whole checklist of things here that science is. It focuses on the natural world. And likewise, it aims to explain the natural world. Okay? It uses testable ideas and relies on evidence. That's where this comes in here, empirical knowledge, empirical evidence, or empirical data. These are things that are based on observation and experiments. Okay, so this is one of the foundational principles of the scientific method is empirical knowledge. Okay? And then we can talk about how science involves the greater scientific community through peer review. Usually it leads to ongoing research, and it, of course, benefits from behaving in a scientific way by using empirical knowledge. A couple things that science is not. It does not make moral judgments, nor aesthetic judgments. Thank goodness. It doesn't tell us how to use the scientific knowledge that we're gaining. This is a really key component. That's more ethics. Okay? It also doesn't draw conclusions about supernatural explanations or feelings that we have. The scientific method is traditionally presented in the first chapter of science textbooks looking something like this figure here, where it's a simple recipe where we say we identify a problem or ask a question, then we gather data and make observations. From those observations, we generally form a hypothesis, and then that hypothesis gets tested using empirical data. We look at that data, and then we determine, hey, does that data agree with our hypothesis or not? Okay, you've probably seen this over and over and over, and I'm here to tell you, well, it's way too simple. Okay, and the answer to this little cartoon over here on the side is no, it's never too late to completely change one's hypothesis. So let's look at a little more nuanced version of the scientific method, something that I like a little bit better. So this model is from University of California, Berkeley, on their website about understanding science, and this figure shows 4 fundamental parts to the scientific method. Okay, so this first phase, exploration and discovery phase, this is where one makes observations, asks questions, and collaborates with others to kind of form some sort of idea about something that we want to test. Okay, so then this first phase then goes ahead and leads into the next phase, that testing phase. Okay, and this is where we test ideas. We can gather data in this phase, form hypotheses, generate that empirical data, okay, and study that data. And then depending on what happens in that phase, that project may just move right back to the exploration and discovery phase, or maybe it moves on to saying, hey, community, greater scientific community, what do you think about these hypotheses? Okay, or maybe this testing of ideas phase actually led us to developing some sort of new technology, and we need to analyze the benefits and outcomes of that technology. Okay, so there are so many different pathways, and you can see here that all these pathways then lead right back to that exploration and discovery phase, and we can go through this over and over and over. Okay, so this figure, why I like it better, is it shows much more clearly than that early linear figure that the scientific method is iterative and collaborative. Okay, it responds to societal and technological needs through this community analysis and feedback and the analysis of the benefits and outcomes of any new technologies. Okay, this is the cut and dry version on UC Berkeley's website. They have an expanded version that I'm showing here. Don't panic. You don't need to read everything in here. You're not going to test you on the nuances. But just to kind of highlight, we talked about that exploration and discovery phase is asking questions, making observations. And you can actually collaborate here by finding inspiration with others or reading the literature, okay? So there's a lot of different pieces within this. And if you want to learn more about this kind of more nuanced, truthful scientific method, go ahead and check out the UC Berkeley website that I have down here. It's a really comprehensive website talking about the scientific method. Okay. So as we're going through this course, I really want you to remember that these scientific models that we construct using the scientific method, they're based upon the empirical evidence available at the time that we construct that model. Okay, so these models will naturally change and grow as society and technology allows us to perform more complex and nuanced experiments. So here in this first figure, we're looking at the Bohr model of a lithium atom. We're going to talk more about the Bohr model of atoms. And this is the common representation of atomic structure that was proposed by Niels Bohr in 1913. But we now know that this model is even simplified. We still use it because it's really useful for us. Okay? But it's still a simplified model. Down here, we're also looking at some chemical structures of hydrogen, so diatomic hydrogen, diatomic oxygen, and all the way up here to the model of glucose. Okay, these are all models. These are representations of how we as humans make sense of our natural world. So one of my favorite quotes to keep in mind while learning about any new science is, "A model is a lie that helps you see the truth." Okay, so keep this in mind throughout our class, right? These are simply models that I'm going to teach you. They're models that work and that are based upon empirical evidence, and lots of empirical evidence. We're in general chemistry. This stuff hasn't changed for a really long time, okay? But our models are still limited to observable phenomenon and limited by the communication that we share. So in this room, the communication models are English and mathematics. Okay, and that's all that we've got to communicate about general chemistry. So likely our models are incomplete. So keep that sense of humility as we're learning this.